Hi again, everybody. Chris Tisdale here again. Thank you for joining me. In this presentation, I'm going to continue my series of videos on geometry and geometric construction. In particular, we're going to use a circle arc template instead of a compass, and we're going to use a straight edge to complete these constructions. And these constructions are usually seen in high school. So let me show you the tool, and then I'll show you a construction. So let me share my document camera with you. So this part of the tool is called a circle arc template, and it's about 300 degrees, and you can put the center on a particular point, and you've also got a straight edge. Now, this is part of a bigger tool called a Mathemat, and there's lots of shapes and markings there. But for this presentation and for my whole series, all you need is this circle arc template and a straight edge. And in particular, you don't even need the markings on them. And the idea is to use this circle arc template to replace the compass that you see in high school geometry. There are lots of problems with compasses. They're difficult to use. They don't produce very accurate drawings, and sometimes they can be unsafe. So let me show you what I mean by a construction. Let me grab a pen here. In this video, I'm going to show you how to construct a perpendicular line from a given point C to the line segment AB. Okay, this is a classic problem. It's literally thousands of years old, and I'm going to be using these new tools to do it. So let me write down the actual construction. So construct perpendicular from the point C to the line segment AB. So let me highlight that. So what are we looking for? We're looking for a line segment that goes through C and is at 90 degrees or a right angle to the line segment AB. Now, in my previous video, we had the point C was on the line AB, and we had to sort of construct a perpendicular to that point C. Okay, that's also on the line. Here it's slightly different. C is no longer on the line. Okay, so how do you do it using these tools? Well, it's very similar to what you do with the compass. And in particular, the moves are very similar to constructing a perpendicular bisector of a line segment. So this construction can be related back to an earlier construction that I looked at. All right, so how do we do it? Well, the first thing I'm going to do is I'm going to place my circle arc template so it's centered at C. And I'm going to draw an arc. Okay, and you can see that this arc cuts AB at 2 points. Let's call them D and E. Okay. Now, what I'm going to do next is basically use this perpendicular bisector argument, right? So I'm going to basically perpendicularly bisect this line segment DE. And because CE is a radius, CD is a radius, if I say put an arc here and an arc here, but with those points as center points, C is going to lie on both of those circles. So let me, I guess I can move to purple now. So let me, I guess I can do this one first. Let me put the circle arc template with center D, and I'm going to draw an arc. You can see that it contains the point C. Whoops, let me fix that up. And then I'm going to repeat that process over here with the point E. Okay. And so now the point C lies on that point of intersection. It is the point of intersection here. There's another point of intersection for those two arcs that I just drew. And the very final step, you've got these two new points, and we're going to draw a line segment connecting them. So let's call that, let's call the new point down there, say F. Okay. And very last part, use the straight edge to draw in that final part. There we go. Okay. So that is the construction. I've continued it all the way down here to F. So let's, I guess, label a new point. Let's call it A, B, C, D, E, F. Let's call it G. Okay, so CG is perpendicular to the line segment AB, and that's exactly what we wanted. So what about some justification? Well, they're the moves, but let's think about how we might justify it. Well, basically, if we want to summarize it, we perpendicularly bisected the line segment DE to form, let's say, CG is fine. Okay, and we know this from an earlier construction. So the angle here must, so CG B, let's say, must be right angled. Let's put B in, they're the same angle. So it must be a right angle. And hence CG is perpendicular to our given line segment AB. Awesome. Okay. Now, what happens if you didn't know about that perpendicular bisection? Can you still start with this, do the moves, and come up with some justification? Well, yeah, you can. If I draw in a couple of extra parts here, so that's a radius. That's a radius. That's a radius. And that's a radius, okay? And so these lengths are all equal. All right, so how would I actually, if I didn't know this about perpendicular bisection, how would I actually show that angle, say, CGB is a right angle? Well, you can do it using similar triangles. So let me come down here. So alternatively, you can show that the triangle CDF is congruent to triangle CEF. by side, side, side. So that means that all the corresponding angles are equal. So this angle in here has got to equal this angle in here. And so triangle DCG is congruent to triangle ECG. That's by side, angle, side. Okay, because side, the angle is the same, and side. Okay. So that means that that angle has to equal that angle. All right. But I won't concentrate on that too much because I've already talked about that in a previous video. Now, one really good question here is, well, with that first move, Chris, where you cut AB twice with that circle, what happens if your tool is not big enough to do that? So let me quickly discuss that. It's not a problem. So let me start with a new diagram. Let's say I had, so let's say here's my original. Let me just push that up a bit. There we go. And let's say my given point was up here. Okay, so now I've got A, B, and C. So if I try to start the process with my circle arc at center C, well, if I draw an arc there, it's not going to cross AB. So what do I do? Well, it's not a problem. What you can do is just choose, say, an arbitrary point that's close enough to the line. Okay, let's call that a new point. Draw, and you would construct this. I've shown you how to do this in a previous video. You would construct a line that's parallel to AB. And then what you would do is just repeat the process and drop a perpendicular from C to this new pink line. And if you extend it, it'll also be perpendicular to the original line. Okay. So whether or not your point is close or far away, the circle arc template can still handle it. All right, folks. Well, thank you for watching. Join me again for more presentations on this constructive geometry. Hope you're enjoying the series so far. Let me know what you think. Let me know what your experiences have been like with using compasses. And let me know what you think of the new tool. All right. Thanks, everyone. Bye.